Hello everyone. நம்ம இன்னைக்கு பார்க்க போற டாபிக் என்னன்னு பார்த்தீங்கன்னா the properties of Maxwell's equation நம்ம வந்து ஒரு வீடியோ போட்டிருக்கோம். அதில் ஒரு முக்கியமான ப்ராப்பர்ட்டி என்னன்னு பார்த்தீங்கன்னா the Maxwell's equations are symmetric under the exchange of E and B only for some special class of only for special case. அது என்ன கேஸ் அப்படின்னு சொன்னதுன்னா only in free space அப்படின்னு சொல்லியிருந்தேன். So let me clarify that in detail. So நம்மளுக்கு Maxwell's equation first எழுதுவோம். So Maxwell's equations. Okay. Now the first Maxwell's equation which we wrote last time is equal to del dot E is equal to rho by epsilon 0. Let us call this equation number 1, Gauss's law. Del dot B is equal to 0, you call it as equation number 2. Del cross E vector is equal to minus partial B with respect to T, you call equation number 3. Del cross B vector is equal to mu naught J plus mu naught epsilon 0 partial derivative of E with respect to T, you call by equation number 4. Notice that in the equation number 1 and equation number 4 we have source term. So this equation number 1 contains a source term, that is charge density. So this is called source. And this equation number 4 also contains source. This is called current density. So this is actually source. So here the source is charge density. Okay. Here the source is current density. And Maxwell's equation 2 and 3, there is no source term. There is no source term. Okay. Suppose let us take a case like this. If there is no source, if there is no source, which means then what happens here? So இது என்ன அர்த்தம்? When source இல்லை அப்படின்னும் போது then rho is equal to 0 and நம்ம J என்ன எடுப்போம்? J also taken to be 0. That's it. So for example in vacuum அல்லது free spaceல என்ன இருக்கும்? So rho is equal to 0 here and J is equal to 0 here. Then the Maxwell's equation enna agum appdi pathina, we can write the Maxwell's equation as divergence of E vector is equal to 0, you call it as equation number 1. Divergence of B vector is equal to 0, you call equation number 2. Curl of E vector is equal to minus partial derivative of B with respect to T, you call equation number 3. Curl of B vector is equal to mu naught epsilon 0 partial derivative of E with respect to T, you call it as equation number 4. Okay. So null equation எழுதியாச்சு. Now look at this, there is no source term because I wrote the Maxwell's equation for the free space or vacuum case. இப்போ இந்த equation வந்து symmetric under the exchange of electric field and magnetic field அப்படின்றத நம்ம பார்ப்போம். Suppose I choose, let us choose E to be B. Electric field B அப்படின்னு டைரக்டா நான் கன்வர்ட் பண்ணிக்கிறேன்னு வெச்சுக்கங்களேன். Then when I choose B to be minus mu naught epsilon 0 E vector, then in the null equation எப்படி மாறப்போகுது அப்படின்னு பார்ப்போம். So let us take this. So when so what about to the electric field? So let me write down these equations once again. So curl of this E vector is equal to minus partial derivative of B with respect to t. Curl of B vector is equal to mu naught epsilon 0 partial derivative of E with respect to t. When I choose E to be E as B and B as minus mu naught epsilon 0 E vector, now the above said Maxwell's equation எப்படி இருக்கும்? The first ரெண்டு equation வந்து மாறாது. பாருங்க, when I substitute this, so what I will get? I will get divergence of B vector is equal to 0 because E is changed to B. So second என்ன ஆகும்னா divergence of minus mu naught epsilon 0 E vector, that is equal to 0. This implies since these two are constants, I can pull out from the derivative. Okay, so minus mu naught epsilon 0 divergence of E vector is equal to 0. Since the constants cannot taken as 0, so the only choice is divergence of E vector should be 0. So this is the next. So the first two equations, you notice that they are same under the exchange of electric field and the magnetic field, like this, right? So further we can also check the other two equations too. So இது எப்படி பார்க்கலாம் அப்படின்னு பார்த்தீங்கன்னா, so divergence curl of E vector which is equal to curl of E vector, E க்கு பதிலா நம்ம என்ன பண்ணணும், B ன்னு மாத்திக்கலாம். So let me change E to be B and minus partial derivative with respect to t. B வந்து என்னன்னு பார்த்தீங்கன்னா B is equal to minus mu naught epsilon 0 E vector. So mu naught epsilon 0 minus into minus plus ஆயிடும் partial E vector by t. So once when I substitute this transformation in equation 3, E இந்த இடத்துல என்ன ஆகுது, B ஆ மாறிடுது and B க்கு பதிலா நான் இங்க substitute பண்ணேன். Substitute பண்ணா என்ன வருதுன்னு பார்த்தீங்கன்னா I am getting the equation number 4. Similarly equation 4 எடுத்துப்போம். Let me substitute here. Curl of B க்கு பதிலா substitute பண்றேன். Minus mu naught epsilon 0 E vector which is equal to mu naught epsilon 0 partial derivative of with respect to t, and this is B. E வந்து B ஆ substitute பண்ணிக்கிறேன். And notice that this can be written as minus mu naught epsilon 0 curl of E, that is equal to mu naught epsilon 0 partial derivative of B with respect to t. So in the constants la cancel பண்ணிடலாம். So this can be rewritten like curl of E vector is equal to minus partial derivative of B with respect to t. So we start with equation number 4 and we end up with equation number 3. So this means what? These Maxwell's equations are symmetric under this transformations. Okay, so thanks for watching this video.